Okay. So third topic is normal matrix. And we haven't talked about normal matrix. Hopefully Professor Dave's talked about it in class. But let me give you an example of a transformation here that could happen. Not this. I wanna annotate. For example, imagine a triangle or that has this normal, right? If we multiply this, so this has vertices v1, v2, and v3. If we scale this guy, or do a non-uniform scale, like this, let's say, if you scale it on the y-axis only, our normal changes a little bit. The normal is not the same normal anymore. And let's say this is a scale. This is a scale. And y. So our normal changes direction. So this is kind of like a model matrix that we multiply. To do the scaling, we're going to use a model matrix, right? So we can actually you can kind of have this notation here: v prime equals to m times v. So this is our model matrix, and this is our original v1, v2, or v3. We do this in the shader times, right? We could do this in the shader as well, and m times n. We could try to use the same model matrix to transform the normal and get the normal right. But it turns out this math doesn't work. And in the assignment, actually here, there is a description. I'm going to go there in a bit. But there is actually a nice article explaining why this doesn't work. And it also explains the solution. So the solution is to use another matrix. Let's call this kind of the normal matrix. I don't want to use n, but another matrix, let's say A, that is actually equals to the model matrix, the inverse of the model matrix, transposed. If we use A here, then we get the right normal for this scaled triangle. Did Professor Daves talk about this today in class or not? Okay, so the problem is quite actually important because again, especially for, let's say, for your animals, I think you might be doing something like this kind of scales. For the world, for the cubes, this won't be a big of a problem. But for the animal, I'm sure it's going to be, because a lot of you are doing like very different types of transformations, and then your light won't look right if you don't use this normal matrix. I'm calling it A now, but you have to actually pass this new matrix to the shader as well. And the book also talks about this. In the lighting chapter, it talks about this issue. Let me show you an article that has like the clear math of why this doesn't work. I'm not going to go over it, but just want to point to the reference so you can go and read if you are interested. Oh, sorry. This is here in the resources. There is a normal matrix article here. and it uses, I think, the same. I grabbed the same example. See, like here, for example, if you have this original triangle and then you have this original normal, if you kind of scale it up on the y-axis, you get this tilted normal here, and you have to fix it. So the naive approach would be to multiply this original normal by the model matrix, but it doesn't work. And then this is the math, kind of like to the algebra to get to the result that I just mentioned, which is this one. So actually he's calling my A actually G. So the final matrix that you need to multiply the normal by is the inverse of the model matrix transpose. Okay. I want to actually do this with you here, because this is also like a point that a lot of students get confused and kind of either like some of them avoid, and then later there's problems. So I want to go over this. It's just a minor mathematical detail they don't have to do. But okay, actually, any questions about this problem? Okay, so I'm going to implement the normal. I'm going to actually make another matrix here. I'm going to call it, oh, not 5. Normal matrix. Okay, this is an uniform. So we have to kind of have a variable for it here in the JavaScript side. Here. We have to retrieve it from the shader down here as well, like the other ones. I'm going to do here, retrieve normal matrix. This is this. And we have to set that uniform to be this, guy, the inverse of transpose of model matrix. Where do we do that? Well, we're gonna have to do that where we give the normals, where we give the, so where we have the model matrix, right? So here we have the model matrix. We're gonna have to do this for each geometry, because each geometry has a different model matrix. So we're gonna have to actually here update shader with the normal matrix. And we're gonna do, actually this is gonna be, no, normal matrix. But here we're gonna have to compute this G matrix, or the normal matrix. I'm gonna say normal matrix equals new matrix 4. Then what is normal matrix? Normal matrix is the inverse of the model matrix. Let's do the inner operation, which is the inverse of M. Our library has a function called set inverse of. So if you go to the library, you have this function called set inverse of, and you give a matrix here, and then it gives you as a return, it returns that the inverse. So I'm gonna do set inverse of geometry.model matrix. And we also have a transpose function, which is transpose. We have a transpose function already. So we can call normal matrix transpose. I'm gonna do this compute normal matrix, and then update the shader with the normal matrix. And this is gonna be normal matrix of elements. Okay. One last thing is, I've mentioned this many times, I don't like creating objects, especially matrices and vectors inside the rendering loop, so I'm gonna put this guy outside. See that every time I'm gonna set here to be a new matrix. So this is gonna reset this matrix all the time. I don't have to create a new object every time. So I can do this as a global variable, and I can actually specify it down there together with the other matrix. So this is a global matrix that I keep it outside, so I don't have to create a matrix on every draw. I think this is it. But one last thing is we have to use this. We have to actually use this here. And essentially what you have to do is multiply the normal by the normal matrix, right? So we can just do this. But wait, A normal is a vector, A normal is a vector 3. So I want to make this a vector 4. Because this is a 4x4 matrix, it has to be, I want to just make this a vector 4. And I want to make V normal a vector 4 as well. So note the difference here. This makes sense because I'm extending the normal here, and I want this to be vector 4 as well. So now we have the fixed normal, and that's it for the normal matrix. Let's see if this runs at least, if I haven't. Oh, I see. For the first time, we actually have this problem. We are calling, this is a global scope, and you're calling new matrix 4. So let me see about the order of my scripts in my HTML. Yeah, that's why. Honestly, this should be the last guy. These should become like this, and then maybe world and camera. This is a much better order. Load geometries, then load. I'll call this load like kind of geometries, and then maybe load game. And I'm gonna call this game scripts. Okay. Now it should work. There's also like a problem in my shader. Failed to compile shader. Constructor, too many arguments. What did I do? Did I? $0.19. Oh, no. No, this is right. V normal. It's a problem. Vector 4 times, let me go back. Maybe to what it was before. It was like this, right? This was a vector 3. So you're saying check line 88 of Q1 matrix. Wait, why does it, why is that? No, it doesn't say anything about. No, this is Q1 Uchuls. This is a shader. This is a shader compilation problem. It's a problem in the shader. Wait, let me just try this. So let's see, V normal. Now these guys are vector 3, vector 3. Let me see again. Okay, this is working. So let's do this slowly. Vector 4, vector 4. Now I'm going to just cast this to be vector 4, 1. Oh. Okay. Vector 4. Too many arguments. Why is that? A normal? Hey, let's see something here. Vector 3, A normal. $11, false. This is good. Wait, what is the problem here? Oh yeah, that's true. Oh yeah, thank you. The problem is here. No. Yeah. Am I using the normal somewhere else? Because this is a vector 4, V normal, A normal, vector 4, vary. I'm casting it to be vector 4. And now I have to use what's going on? So this casting is giving us some problems. A color equals B color, A normal, V normal. For some reason, this is giving us some failed to compile shader constructor, too many arguments. Normal matrix, uninormal matrix. Then the draw here, we give normal matrix dot elements. This is correct. Let me set this to be, let's say, vector. We go vector 4. Yeah, it seems that the problem, for some reason, is in this line. Let me see. This, if I keep this guy the same, for some reason, this works. Sorry. So this was working before, right? Now this also doesn't work. A normal, V normal. Let's get back. Let's go back to the state where it's working. I think this is working. Yeah, this is working. Okay, this is working. But if I, let's say, if I use my normal matrix here, and let's say if I multiply this by a vector 4, and then if I, let's say, just as a kind of a hack, if I do this a vector 3 again, or if I, now it works. Huh, interesting. Wait, I'm missing something here that I don't see what's. Yeah, I don't see what is the problem. Well, what we can do, what we can try to do, let me try something. Let's try something. Let me do, this guy, vector 4. So if you do vector 4 here, we can pass a vector 3, is going to cast correctly. So what happens if I do this? And now this is a vector 4 a normal, but this is still vector 3. And now I can cast this to a vector 3. Okay. Huh, this also works. But if I actually keep this as a vector 3, and then I have to cast a vector 4. Okay, that's weird. I'm going to keep it this way. Yeah, that's weird. It's still working. The normals are correct. I think this actually is a bit better. Because here we actually, it's better to have the vector, the normal is a vector 3. It makes more sense than vector 4. Yeah, I think this is better. I'll investigate why this is, this was a problem. Something that is useful here is also to kind of normalize. So if you normalize a vector in the shader, you have this function normalize. And I think it's useful to do this already here. So make sure your normal is normalized. I mean, it has like length 1. So I'm going to do this. Okay. It doesn't change because our radius, the radius of the sphere is actually 1. But if it's kind of, and it's always 1 because you created it to be, you never change the radius of the sphere. And if you actually do, if you multiply, if you actually scale it, it won't be a problem as well. Yeah, so okay, so you're saying that the professor recommended normalizing both shaders? Yes. I mean, you won't, I don't think you're gonna have to do it, because if this is normalized, Okay, I think he's saying that because like of interpolation and kind of. So then I think if you're doing normalization, you should do it always here then. So here you can actually do, for example, a vector 3 normal equals 2 normalize. I think this is actually better. Normalize v normal. Or we can call this our n. This is our like big N. It's on normal. And here we can use n. It works. Okay, this is good. This looks good. We've passed the normal. We have actually multiplied by normal matrix. So we are good with any transformations now.